Hello everyone, welcome to Crank Software's Embedded UI Live series. Today we're going to be talking about working with remote teams on embedded UI product development. My name is Thomas Fletcher and I'm VP of R&D here at Crank Software, where I look after our Storyboard embedded UI product development team. I'm going to be sharing with you some of my experience working on embedded UIs and embedded development in this series of live sessions. We're going to try and make it as interactive as possible, and so in that vein, if you feel like entering comments, you'll see that I'm looking over here from time to time, checking at my laptop, making sure that there's no comments that are coming in that need to be addressed. But if that doesn't work, we're doing these sessions on a fairly regular basis. We're going to try and put one out every couple of weeks. So we'll try and catch those questions up there in that sense. So as I mentioned, today we're going to be talking about working with remote teams on embedded UI development. It's a very timely topic given the current situation of the world, where a lot of teams have been broken out of the office and they're all working from home. What I want to talk about today is I'm going to talk about two different staff members that are part of an embedded UI team and how they might work together and collaborate with one another. So I'm going to use the names Eddie and Ingrid. Eddie is my hardware developer. He is working, and I've got something here I can put up on the board here. He's working at home, probably on his kitchen table right now, with this embedded hardware. This team is putting together some sort of a new coffee machine, and so he's got the hardware at home, and he's working on the firmware. He's working on the I/O controllers, the device drivers. He's looking at how he's going to get input from the system and be able to relay that data into other parts of the system. So Eddie is one of our developers, and as I mentioned, he's working from home, right? Ingrid is our other developer. She is also working from home, but she has a different role in the team. Her role is to incorporate the content from the graphic design team, right? And here we're talking about Photoshop content, Illustrator content, the graphic design elements that have been put together for this coffee machine product. She's working on integrating that graphic design and bringing that into sort of a user experience, right, to reflect the reality of their embedded product. She is really kind of looking at different technologies, and the technology that she chose, of course, is Storyboard. Now, there are other technologies that you could use for your embedded UI development, but in this case, she's using Storyboard to help bring that Photoshop content in and then rapidly realize the user interface and do all that in a desktop environment, right? Working to take static content, put together animations, user interactions, the screens and the modalities of the application, be able to kind of put all that together. So Eddie and Ingrid, two members of a team. Typically, if they were actually in the office working together, they probably would be working independently. They're working on very different areas, and so there's not actually a lot of tight coupling between them. But as a team, they're probably used to getting together and sort of just bouncing ideas off of each other. And so that doesn't really change in our work at home environment. So I should also indicate here, Ingrid, she's also working at home, but she's just working with a laptop. She doesn't necessarily have any of the hardware. So their integration right now is probably using Slack, right? Probably using Google Hangouts, Zoom calls, the same as everybody else in this current situation where, IT workers are able to work from home fairly effectively because we can bring our tools with us. They probably have a shared repository for their team where they put all of the content for their UI development, for their embedded product development, right? The whole system images. And there's probably a whole cast of other team members who are working alongside them. But we're going to focus on Eddie and Ingrid in terms of the work that they're doing. Now, Eddie can work just fine. He's doing C development. He's doing his compilations. He's interacting with his hardware locally. Ingrid, same thing. She can work in parallel with Eddie. She can be doing the UI development. She can be working at a desktop level. Storyboard allows you to simulate and work in an environment that doesn't require the embedded hardware, right? So you can build all that. But part of the essential design choices, right, that go on here is how do we get, sort of this, we'll call this the back end, right, component, and our front end talking to one another, right? What does that coupling look like? And if you're familiar with back-end, front-end terminology, it's a web terminology as well. You know, front-end typically talking about the browser, back-end talking about the server. In embedded development, back-end and front-end tends to play the same role. The back-end is usually the device drivers, the system logic, maybe even in some cases the business logic of what the application is. And the front end is the user experience. The front end is what the user is actually engaging with, touching, interacting with, sort of that type of experience. So the question becomes, what kind of contract do you have for exchanging data back and forth between the back end and the front end? A typical environment in an embedded capacity might be that the front end and the back end tied coupled very closely together, right? It might be that you're using a graphics library and you're calling into C functions, and those C functions are not only manipulating the user interface, but they're also communicating data from the back end to the back end or receiving data from the back end. That's not an ideal scenario when we're all working remotely. It introduces too much coupling. What it means is Ingrid would actually have to tie directly to a source repository that Eddie would also be working with. At the same time, they'd have to synchronize their commits. They'd have to ensure that they're always kind of working in sync in that capacity. Very sort of lockstep operation, right? Ingrid can't introduce a new callback function until Eddie has the functionality ready to go, or she has to stub it. So a better way of working is actually to decouple this, keep the same logical operations of a back end and front end, but instead couple them together with events, right? And the idea here is that with an event flow back and forth, what your event flow is doing is it's giving you a contract, it's giving you an API, and how those events flow back and forth, right? If you're using an embedded system, you might be using a message queue, right? A message queue by which the back end, the hardware, can communicate up to clients like the UI that are interested in data with a series of events with data payloads that represent the system state. And similarly, the UI can communicate to the back end using a different set of events with a different set of payload, right? So this type of decoupling means that you're changing the transport and decoupling it from the actual data payloads and the information that's being relayed. What that does is it allows a simulation to occur in a much easier fashion, right? Ingrid can work independent of what the hardware is doing, and at the same time, when we look at what Eddie is doing, Eddie doesn't need to know what the data is actually doing. Eddie doesn't need to know, or sorry, not what the data is doing, but what the UI is actually doing with his data. So, by the same token, right, he can have his own feedback loop here, and in his case, he's simulating the UI, right? So this in this case would be simulating the back end. And that's that API contract, right? So this is, sort of part of a good design. Now I'm just going to pause here. I got a little bit of an update message here. Just want to check and make sure that we're on track here. Things look like they're going well. I've got some messages from my audience. All right. Oh, I've got a message from Kyle Fletcher. Kyle Fletcher, great last name. Fantastic. Good to hear from you. You don't seem to have a question yet. You're just getting on board. Fantastic. All right. So what I want to know now is what's the next step? So Eddie and Ingrid, they've both been developing their software. They've both been, kind of working through the system. Eddie's really excited. He's got his back end working. He's ready to go. He's got data coming live from his hardware. So what's the next step for him? Ingrid, on her side, she's also got the UI working. It's ready to go. She's been simulating. It's got a good feel. She's been working at a desktop level. So, what is she doing? She's got the desktop simulation running, right? It's working with simulated backend data. But what we'd like to do is we'd like to connect these two guys together, right? So this is our scenario number one. What we're going to do is we're going to set up an environment where now the hardware can actually be providing information to the desktop UI, right, and replacing our simulated backend. Now, this might occur by Ingrid pushing her project into a source repository and Eddie having to pull it out. But that means that Eddie now has to know how to configure the UI and get all that stuff going, and that's not really his thing, right? Similarly, if Ingrid had the hardware, she'd have to figure out how to get the system image going and all the rest of it. Also, not really her thing. So what we'd like to do is we'd like to leverage the fact that we've got a network connection. We already have Eddie and Ingrid talking together in an informal fashion as part of their kind of collaborative team. So let's extend that and push that down to the embedded hardware, right? Let's push that down to their embedded system that they're building. And so what we can do is we can leverage, for example, a TCP/IP channel to send the events. And so with a little bit of configuration on Eddie's side, what he can do is he can have his hardware that he was probably already connecting to remotely. He can have his hardware redirect its I/O over a communication channel that can be funneled across the internet into Ingrid's simulated UI. Now this is really powerful because what it means is that Ingrid and Eddie can work together in one channel, for example, a Slack channel. They can be talking. Eddie can be generating inputs here on their application, and those inputs are flowing directly as they would from the hardware, because they are coming from the hardware, all the way into the user interface. And Ingrid, as the owner of the user experience, she's able to monitor that live data. Now this is data that's really coming from the hardware, and she can validate any assumptions that were made around the event API that was previously put in place, right? There's always going to be a little bit of kind of misunderstanding or lack of clarity, and the idea here is to reduce that, and Ingrid can quickly jump on to UI adjustments that need to be made in her local environment. Similarly, if there's something wrong with the data being generated, Eddie can jump on that in his environment, but they don't actually have to exchange any source code. They don't have to exchange any configuration information. They can work really effectively in this manner, right? And it's not just about events going one way. Similarly, right, we can have those events flowing down to the hardware from the UI in a simulated fashion, right? So that's the first step, right? We've got a clear API, we've got event decoupling that gives us the ability to work in parallel. Now what we've got is we've got the two team members working effectively and bringing their individual elements together, but still separately. What's the next piece? Well, ultimately, what I'd like to do is I'd like to take that user interface and I would like to run it right on top of this hardware. So if I can get that stage going, then this team is ready to start sharing these two components with the rest of their team members, right? They can now start talking about pushing it to the source repository without any concern. So this decoupling now goes into sort of our third phase, which is now what I'd like to do is on this hardware platform, what I'd like to do is I would actually like to run Ingrid's UI, right? So I would like to put the UI onto the display. Now, you might be thinking, well, okay, well, that's easy. Ingrid just takes her work and she pushes it out into the source repository. Eddie will pull that up, he'll do the configuration, and he'll build it. Sure, that's definitely possible, but at that point in time, the whole team's seeing the configuration, even if you're using branches. And maybe there's iterations that need to go on, there's some tuning that needs to go on. It's better that Ingrid and Eddie can continue to work, kind of effectively coupled together in their independent areas, rather than just sort of hand it off and say, okay, now you try it, right? If Ingrid can stay in the loop on UI changes that need to be made, and Eddie can be right there to respond, we know that the hardware interaction and the data going in and out is going to work. What we really are trying now is making sure that the visual representation of the UI is accurate, that it's actually looking right on the device. So for that, Ingrid can deploy from her storyboard environment. Again, we have a network connection. So she can deploy from her storyboard environment all the way down to the target using our secure copy and SSH connections, and she can own the experience of pushing down her current UI development all the way down to the hardware. Eddie can sit there watching the hardware, or even better, he can take a webcam, just like what we've got right now. He can point it down to the hardware, continue to have that Slack conversation with Ingrid while she's watching the hardware and looking at the interaction. And so this type of transfer allows her to control what's being pushed to the embedded target. It allows Eddie to really focus on, is the system doing what it needs to be doing? And they can work collaboratively that way, and then they get to see it really running on the hardware. And that's a really, kind of 3 very distinct steps to kind of move it along. Now, of course, the glitch in all this is Eddie was so excited about getting his data going, from his regular I/O connectors. That was really kind of his sole focus. He wasn't focused on the UI, and maybe to that end, he actually totally forgot about doing the touchscreen driver. And so that work is still pending. Now Ingrid's pushed her UI to the hardware. What is she going to do, right? It's a touch interface, perhaps. They want to be able to actually not just see the data coming from their sensors into the UI, but actually simulate what the user experience looks like. So she can do that too, because again, the event-driven nature, we're just going to leverage the same communication channel that we had going on here when she was running the UI on her desktop down with simulated data from the hardware, providing input to it and receiving data from it. We can take that same channel and she can generate input from the UI. Right, a little awkward here, we're down at the bottom of the whiteboard. But she can generate the input from the UI, and she can either do that directly from her development environment. We're using an IO connector, something that can generate events, or she can provide Eddie with, perhaps an automated playback file, right? Something that allows us to take events that would be normally generated by the user touching on the screen and inject them into the user interface. So, these are technologies that, yes, I'm talking a little bit about what Storyboard can do, but in general, when you're doing your embedded UI development and you're talking about decoupling your teams apart from one another, whether it's in the office so that they can work in parallel and work effectively, or in this case, because we're all working from home and we're actually physically distancing ourselves, so we can't actually just come over to someone's desk and look and say, okay, can you run this on the hardware now? I want to take a look at it, right? So it's a slightly different mode of operating, but it's not actually too distant from a normal operation you'd see. And actually, everything you're seeing here is really good practice from an embedded architecture and design perspective to get that decoupling, right? To allow people to work independently and in parallel. So, just to kind of summarize, keeping your abstractions clean, right? Allowing them to be decoupled, right? The event-based interface. Keeping your options open in terms of modes in which you can share elements of the front end and the back end, right? Being able to test independently and kind of push your way through, and then being able to kind of stepwise move your product along without necessarily engaging the whole of the team in your effect. Because at the end of all this, when we get down to this point, what we have is we've got something which is almost product ready, right? It's ready to go into a repository, be shared with everybody else. Eddie and Ingrid can be very, very confident that what they've built is solid and it's working on real hardware. Thank you very much for your time today. Like I said, we'll be doing these sessions on a bi-weekly basis is our hope. If you have comments or questions, feel free to leave them in the comments area, and we'll try and incorporate them into our future sessions. I'm Thomas Fletcher from Crank Software. Thank you very much for attending our Embedded UI Live series.